inspiration from vernacular. For many regions, bamboo is a native plant and it is a sustainable material considering the energy consumption in its process of production. Bamboo can be treated as a sustainable, vernacular and aesthetical material in architecture. And hopefully today we will get wider information as well as inspiration from bamboo structure. Now I welcome Architect Kazi Ghulam Nasir, President IAB, to deliver his welcome speech. We would request you to kindly keep your mobile phone silent throughout the presentation.
Shubho Sandhya. Good evening, dear fellows, members and associate members of IAB. Today's speaker, Dr. Andrew Noko and Architect Ifan, Mr. Tomal Kanti Shaha, VP South Asia, all other representatives from Kohlar, our member architects, good evening. আমরা আসলে লম্বা একটা সময় নিয়ে কথা বলেছিলাম কোহলারের সাথে গত 5 থেকে 6 মাস যাবত। কোহলার ইনস্টিটিউটের মেম্বারদের জন্য একটা সেশন করতে চাচ্ছে ইন্টারন্যাশনাল আর্কিটেক্টদেরকে নিয়ে। সেই আলোচনাটা একাধিকবার করার পরে আজকে সন্ধ্যাটায় সেই সেমিনারটা অনুষ্ঠিত হতে যাচ্ছে। এখানে আমাদের দুজন বন্ধু আর্কিটেক্ট এসেছেন ইন্দোনেশিয়া থেকে, তারা তাদের কাজ দেখাবেন এবং সেই কাজের উপরে আমাদের দুজন শ্রদ্ধেয় স্থপতি বশিউল হক স্যার এবং স্থপতি নাহাজ খলিল আলোচনা করবেন। তারপরে আমরা দুইজন আর্কিটেক্টের সাথে কথা বলবো। সময়টা খুব জটিল সময়, সন্ধ্যা 7টা বাজে। অনেকেই মনে মনে উসখুস করছেন যে 8টার আগে শেষ হবে কি না। আমরা চেষ্টা করব যত তাড়াতাড়ি পারি শেষ করতে। আর খেলাটা রিপিট দেখতে পারবেন, প্রেজেন্টেশনটা রিপিট হয়তো আর হবে না, তাই সবাইকে অনুরোধ করব যে একটু ভিন্ন মাত্রার যে সেমিনার, সেই সেমিনারটা আপনারা মন দিয়ে উপভোগ করেন, ভালো লাগবে আশা করি। আর থ্যাংক ইউ Kohlar for your kind support. We think that it's a good start for IAB and Kohlar and we'll go for a long journey in future. Thank you very much. Thank you all.
Thank you, Architect Kazi Ghulam Nasir. Today we have two speakers from Indonesia for sharing their vast experience regarding research and design with bamboo construction. Architect Ifan Adiwara and Dr. Andrew Widi Janjonako. Dr. Andrew will deliver his presentation on Beyond Conventional Bamboo Construction. Now we can have brief introduction of Dr. Andrew from Architect Ishita Munmun.
Thank you, sir. Dr. Andrew Widiojatnako is an Indonesian professional architect, faculty and researcher at School of Architecture, Planning and Policy Development of Institute Technology, Bandung, Indonesia. Dr. Andrew completed his graduation and post-graduation from ITB and got his PhD from RWTH Aachen, Germany in 2012, where his research topic was traditional and innovative joints in bamboo construction. Dr. Andrew devoted himself to the research on bamboo construction since over the past several decades in Java and in general in Indonesia. Much traditional knowledge on how to build with several bamboo has been lost for paving its way to the modern architecture. After completion of his graduation in 1995, he has been giving lectures and conducting workshops on bamboo construction in various countries like Malaysia, Philippines, Myanmar, Colombia, Australia, besides teaching youth at ITB. He has more than 25 publications and research works on bamboo and its different characteristics and construction techniques. As a pragmatic architect, he has completed more than 40 projects, and including Great Hall OBI, Bamboo Preservation Facility in Ecocenter of Koh Chang, Thailand. He even has 2 patents on bamboo joint with radial compression for tensile, space truss, and knockdown structures, and customized radial compression joint with multi-knots for high tensile strength connections. Dr. Andre has won several awards. He was the award winner for Great Hall OBI as the Best Indonesian Building Construction in Architecture category in 2011. Tempo magazine nominated him as the Bamboo Architect of the Year 2014. Today, we are very happy he is with us to give a presentation on beyond conventional bamboo construction. Ladies and gentlemen, let's put our hands together on welcoming Dr. Andre on stage. Enjoy the presentation. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening, everybody. I am very pleased and I'm very honored to be here, to be invited by Institute of Architecture Bangladesh to be here, to be a guest speaker in this program. I would like to present my presentation beyond conventional bamboo construction. My name is Andre Widyo Wijatnoko. My last name is very difficult to spell. So this is the only name in the universe that you can find, my last name. Okay. I would start with my presentation with giving a little bit definition about the bamboo. Bamboo actually is not a tree. Bamboo is a giant grass, belongs to the family Poaceae or subfamily Bambusoideae. And then in the world, there are more than 1,000 species. And the distribution, you can see here, in range in very almost all over the world. And the most of the diversity of the species is in Southeast Asia and also in South America. Every time I talk about bamboo, I always talk why I use bamboo. This is one. Okay.
Light indicator and another large indicator.
Okay. Thank you. I always talk to the student on why we have to work with bamboo, because when we use bamboo, there are so many advantages. For example, bamboo is a very renewable resource with an amazing growth rate. It belongs to the 5th of the fastest growing species on Earth, and also produce a very high productivity. And also bamboo grows in a variety of conditions. And the good thing also about bamboo is become the carbon sink and protecting against erosion. And it's also very good for watershed because it improves the absorption of the water into the soil. when we talk about the bamboo construction, you can see here there are so many a variety of bamboo construction. As you can see here, there are all of this. I considered this one as bamboo construction. But instead of, if you see, take a look, it looks like concrete construction. It looks like a timber construction, but actually this is also belongs to the bamboo construction. That's why I make a kind of classification in bamboo construction, and the best way to classify it is by the form of the poles that is used. For example, this belongs to the bamboo poles construction. This belongs to the split bamboo construction. But further than that, in the upper part, as you can see here, bamboo is used to replace other materials. And the good or the best sample is like this one. This is a laminated bamboo, which can replace 100% of timber construction. That's why in my classification, I classified the upper part as substitutive bamboo construction, which is, the idea is to substitute other materials with bamboo, which is more sustainable. And then, other than this substitutive bamboo construction, I would call it as conventional bamboo construction. And I divided this conventional into traditional bamboo construction in the bottom part and engineered bamboo construction in the middle part. And this is the construction that I already done, belongs to the group of substitutive and also conventional bamboo construction that I've already done and researched up to now. And first, I would like to give some overview about the possibility to use bamboo as replacement for looks like a brick construction. This is a development of plastered bamboo construction. Why I did this? This is in the early when I go into the bamboo construction, because almost no one in Indonesia wants to live in bamboo house anymore. That's why I try to provide the common image of permanent house instead of masonry construction. And also, the main idea is also to improve fire resistance. By doing this one, I already make a fire test to the system. And the idea is to make a woven bamboo here, and then we have a half bamboo act as a column here and also as a beam. And then everything will be plastered on the outside. So it looks like a big construction. And I've made many prototypes of this building. We can build this one in the workshop and then bring it into the location that we want. And we can build this bamboo structure only one day. And then after that, we can plaster it to become, looks like brick construction, but it's made out of bamboo in the inside. And I make also another possibility using the different types of woven bamboo, like this one and this one. And this is another examples of this structure. This is the research that I've done recently, testing the bamboo plastered wall, and it can pass 2 hours of fire test using the plastered bamboo construction. I think this is also one of the options to provide the common image of brick construction, but using the low quality of bamboo. And if we go back to the classification, I would like to give you about the development from traditional bamboo construction into engineered bamboo construction, as you can see here. Basically, from traditional into, I would say, engineered bamboo construction is getting bigger and wider span. Make it bigger, make it wider span, even make it higher. So this is the main idea of the development from the traditional into the engineered bamboo construction. How to do this is by strengthening the structural element. In traditional bamboo construction like this one, we use only one post here, and then only small pieces of a post here, and then it strengthened using, for example, in here, 12 or 9 poles of bamboo column. If we consider adding this one, it's 15 bamboo column. So it's just strengthening the elements of the structural elements. How to do this? Actually, there are only small steps. In traditional bamboo construction, mostly we use the connection like this one, using the dowel here, and then the dowel prevent from sliding in this part, and to prevent from popping up, we use the rope connection. But this connection is limited only 2 layers like this one. It is impossible to connect more than that. It's not effective. And then the development is just from the dowel and rope, and then it changed into bolted joint using the long threaded rod like this, and also utilizing the electrical drill, and then we can connect even 3 bamboo or even more, much more easier, and it's much more stronger than previously. And then this is the result, one of the results that when I've designed this Great Hall of Outward Bound Indonesia in Jatiluhur, only 2 hours from the capital city of Indonesia. Basically, this is the design of the structure, and the dimension is approximately from here up to there is 31 meters, and from here up to here is 20 meters without any column in the middle. And I use only more than 8,000 bamboos for this structure. And then this is the upper part. I use the high power structure in the entrance, and on top of the stage in there. And this is the floating roof that I've designed. I introduced the use of bamboo as tension element in this part. Yeah, as tension element in this part. And I also introduced the use of hyperbolic paraboloid to have the entrance in front in both ends. And this is the floating roof. Actually, the span of 20 meters I made by making 5 meters of cantilevers and 10 meters of floating roof in the middle. And I use only 30 frame like this, 2-dimensional frame, and then I arrange into radial like this to become more 3D spaces. And this is the main entrance. As you can see here, this is the condition of the building during a kind of bamboo symposium. Yeah, this is another program in this building. The good thing about the structure is the pattern of the skylight above. Yeah, it's really beautiful in the bottom part. The other project that I want to present you is just recently, not yet finished, but this is almost finished, which is Teras Sunda Cibiru. It's like a cultural building in Bandung. Yeah, I make a lot of facilities, but I want only to present the hall, the big hall. Actually, the big hall is like a pentagon with from here up to here is 70 meters, and without any column in the middle. So I solved this problem of wide span structure by using a twisting structure, which is this is the 70 meters. I solved with twisting and then stacking until the above. So this is the design that I've made. Make it like this. And this is the interior part of the structure. And this is the result. It's not finished yet. It's under construction. Actually, it's already stand on their own, but it is not removed the scaffolding yet. Some part is already removed, as you can see here. This is the main structure of the roof. And this is the structure. I use a steel pipe in the bottom part because I need something that is really reliable to transfer all the force into the column below. If we go back to the classification, now I would like to give you about the development from the engineered bamboo construction into the substitutive bamboo construction. This conventional bamboo construction based on the characteristic of the bamboo. But in substitutive bamboo construction, basically it's just try to copy other construction, copy other structure, replace the material with bamboo. That's why the characteristic of the structure in the substitutive bamboo construction is quite similar with the characteristic of the one that is replaced by the bamboo. And the most idea of substitutive bamboo construction in the use of bamboo poles is try to replace the established space structure that is already made mostly from metal, like this, or sometimes also made from timber. Then the idea come up. This is from the book of The Gift of the God from Oscar Hidalgo. And the idea come up how to replace this material with bamboo, like this one. And then some of the experience is already done. And this is some of the example. And the characteristic of the structure is mostly three-dimensional frame, which is in conventional bamboo construction or in traditional bamboo construction, mostly only two-dimensional frame. And then avoiding eccentricity in force transfer, which is in conventional bamboo construction, mostly there are so many eccentricity in force transfer because of the difficulty to connect all the bamboo together, hitting in one point. And using also the steel connection and also the introduction of bamboo poles under tension. In conventional, mostly under bending or under compression. And then the challenge came because of we want to have the bamboo connection which avoiding eccentricity in force transfer, because this is the main idea of this one. Okay, good. And the other possibility, the other aims to have the research is making the bamboo under tension or compression, purely under tension and compression. And it's become a lot of effort, and then try to find the best or the most effective bamboo connection. And the challenge to do that, there are so many challenges. I want to only 5 of them, because of bamboo has the variation in the diameter. Variation not only because one bamboo is different, one species bamboo have the different diameter from the other species. It's also the variation, also the difference between the bottom part and the upper part, for example. And also the variation in the wall thickness. As you can see here, some bamboo have very thick wall, some is very thin wall. And bamboo is also not solid, but hollow. We have in hollow. And bamboo also have a very hard and slippery skin. And bamboo is considered as a cone instead of cylinder. And then in the existing world of bamboo construction, there are so many research also and experimental construction, which is try to make bamboo joint. Some is already applied in the construction, some only in the laboratorium scale, some only in some idea in drawing. Yeah. And although there are so many bamboo joint in the world exist now, before 2012, there is only one classification by Professor Jules Janssen in 2000. Professor Jules Janssen is the professor from Technische Universiteit in Eindhoven in Netherlands, and he classified bamboo joint into 8 groups. And the problem with this classification is that the group H for split bamboo is not relevant to bamboo pole construction. And also, according to the author, the group 3 and group 7 have hardly any practical application, though it is theoretically important, but it is almost impossible to be made in the real world. That's why I tried to make the new classification of bamboo joint in 2012. And my classification based on the following criteria: the ways of force transfer and the position of the connector, whether it is attached on the inside or on the outside of the pole, whether it is attached parallel or perpendicular to the fiber. And a type of joint is considered as a connection between one bamboo and its connector or supporting base. It is different with the classification that is made by Professor Janssen. Professor Janssen, for example, made this picture here as one type of classification, one type of groups. But in my classification, I divided into 2 groups. This is group 5 and this is group 1. And then here is the classification of bamboo joint. The group 1 is transferring compression through contact to the whole cross-section. Only contact to the whole cross-section that is taken into consideration. And then the second group is transferring force through friction in the inner part of the bamboo or compression to the diaphragm. Bamboo have a diaphragm in the inside. And the group 3 is transferring force through the friction on the outer part. And the group 4 is transferring force through bearing stress and shear stress to the bamboo wall in here, perpendicular to the fiber, connected from inside here or from outside. And then group 5 is transferring force perpendicular to the fiber, and group 6 is transferring radial compression to the center of the poles through shear and circumferential stress perpendicular to the fibers. I add this joint because most of my research is basically use these kind of principles that I will present it later. And most of the bamboo use the combination of the principle like this one. Yeah, the combination of group 1 and 2, combination of group 2, 3, and 4. And with tick mark, I can find it already in the reality. This one, not yet found in the reality. And now I would like to go into the development of bamboo joint, which is I already made in 2012. The main idea is very, very simple. The tension that was induced parallel to the fiber is converted into radial compression on the outer part. So the stronger the tension, the stronger radial compression will squeeze the bamboo and generate more friction on the outside. And it's considered as very, very effective bamboo joint. And I made many research, many calculation also in this type of joint. But I would like go into the test. I made 3 samples of this using the Guadua angustifolia from Colombia. And then this is the detail of the joint, approximate detail of the joint. And this is the failure mode. Yeah, the steel wire tear down the bamboo and then going up like this. Yeah, but the strength is very, very high. The average ultimate load capacity is 3.5 tons. It's already very good. However, I try to I try to improve the strength of the of the joint. That's why I go to the next bamboo joint, which is Barcom joint is bamboo radial compression joint with multi-knots. Instead of only using knots here, I multiply into 4 times with the detail of this one. Yeah? And for this one, I use 16 millimeters of threaded rod with the characteristic strength of more than 6 tons. And then this is the test that I've made. 6 tons, 7 tons, 7.3 tons, and its failure is in here, in the 16 millimeters of threaded rod.
28, 50, 60,
6 tons,
70, 75.
the failure is the same. All of the failure is in the threaded rod like this one, and only the small scratch on the bamboo. It means that the capacity of the connection can be much higher than this if we change the properties of this threaded rod. So it's very, very effective joint. And as you can see here, that average load capacity is up to 7 tons, the strength of this joint. With this kind of joint, this is the dissertation that I've wrote. I have only 10 books of this to be sold in this program after this with a lot of discount. Okay, and the application of this structure is already implemented in the 3 mountain building in Bali. This is the 3 mountain building. Previously, it is not used because of a lot of deformation when the wind blows. And then this is the structure. Basically, there are 3 big columns and also a perimeter column. And the very, very long rafter is lying from here to here because it's very, very long, and then it is not work in bending, but works in tension in this part. So this is very, very long, up to 15 meters long of these rafters. And then this is the detail of the joint using the Barcom joint here, and this is the joint that I've designed using this, and it's connected all of this on top of the structure, as you can see here. Yeah, this is the bamboo radial compression joint, and this is the very beautiful structure. It's designed previously in Green School, and now it moves to Pulau Serangan. I think it was designed by Yogstam, one of the bamboo experts in the world. This is the construction. Another project that I want to show you is the bamboo geodesic dome. Basically, we try also to copy another dome, just replace it with bamboo. And I've built this one in only 2 days. The preparation took almost 2 weeks to make all of this connection. And then we erected, assembly this one in only 2 days in Damyang, Korea. It was used for to sell the souvenir during the World Bamboo Congress in 2015. Another project that I want to show you is the bamboo tensegrity. I would like also to introduce bamboo to use for some other structure, which is beyond the conventionality. That's why during my dissertation, I also built this tensegrity structure. What is tensegrity? Actually, tensegrity or tensional integrity or floating compression is a structural principles based on the use of isolated component in compression. This is an isolated component in compression, always made with bamboo, inside a net of continuous tension. This is continuous tension made of steel wire in such way that the compression member, this compression member, do not touch each other, and the pre-stressed tension member delineate the system spatially. So this is like a floating bamboo here. I built this one in 4 hours. My previous structure built in 1 semester with the student. Now I built this only in 4 hours with only 3 volunteers. And I built also the tensegrity wheel structure. The bamboo also is not touching each other. And also make a kind of dome for a kind of meeting in Jakarta Convention Center in 2014. All of the structure is wobble, but it's very stable. As you will see in the video later. This is also high par, but the bamboo here and here did not touch each other. So it's have a feeling of flying bamboo here. And this is another bamboo workshop in Manila in 2015. I make also a tensegrity spare, and you will see the video here. Okay. Another structure that I also try to introduce also to, especially to the student, is a reciprocal frame. Basically, there are so many also workshop making the same like this. Basically, it's very, very easy also to do this one, reciprocal frame. And then I try to develop to make it wider span like this one. Basically, it's like a Da Vinci bridge, but I make some adjustment to have a longer span like this one. And this is the latest reciprocal frame workshop in Kuala Lumpur, Malaysia. After a lot of experience in conducting tensegrity workshop, research also in tensegrity and reciprocal frame, I then invented the new system of structure, which is the combination between these two. First, I would like to give you the main characteristic of tensegrity, that the element is under pure tension or compression. If I made it with bamboo and then bamboo have the compression, and the steel wire will have the tension force. And the main idea of the tensegrity is the compression element did not touch each other. This is the characteristic of tensegrity. In the other part, reciprocal frame, in the conventional way, the element under bending stress. It's not compression, it's not tension, but bending stress. And one element lays on top of each of other element reciprocally. So with the small pieces of timbers, we can have much more span. And then I combine these two to have the reaction. I call it reaction or reciprocal tension. Yeah, it is different between, it's just between these two. Because of the element that I use is under tension or bending stress. Yeah? Different with tensegrity, which is under tension or compression. Different with reciprocal, which is under bending stress. Reaction is under tension or bending stress. The steel wire will have the tension. The bamboo that I use will have the bending stress. But the bending stress, the bending element did not touch each other like tensegrity. It's different with the reciprocal frame, conventional reciprocal frame. One element hanging other element reciprocally. Yeah, it's very interesting to have this structure. And this is the first reciprocal tension that I've made in 2016. Yeah. This bamboo is hanged by these two bamboo here. This bamboo is hanged by these two bamboo here, reciprocally, yeah, to have the very big structure, very effective, and less materials, less than tensegrity structure. And this is as you can see here, this bamboo is hanged by this one is hanged by this one reciprocally. So we can have the very big structure. And this is the latest workshop on advanced bamboo tensegrity structure in 2017 that I want to present in this presentation. Yeah, I would like to, the last, I will show you can you?
Love was.
Okay, this is actually the collaboration workshop between Erfurt University in Germany and then Kyushu University from Japan and Institut Teknologi Bandung, my university in Indonesia. The workshop called Advanced Tensegrity Structure, and the participant was separated into groups, and in 2 days they have from knows nothing about tensegrity, they have to design the tensegrity sculpture with have an amorphous shape. And then in the third days, for 3 days, we built the real tensegrity sculpture, and also we built the reaction dome, which is the biggest that I've ever built. The second reaction that I've already built. So we built it also in our university in ITB. This is the construction of amorphous tensegrity. And this is the construction of reciprocal tension or reaction dome. Yeah, sorry. This is a amorphous tensegrity. I will show you this. This is the reciprocal tension, how it is very stable, although I shake this one. Yeah, it's very stable. I shake this one, but it's very, very still, very, very stable. I did this just before I have to remove this one. So it shows the sense that it's really, really stable, although it looks like shaking. I think that's all my presentation. And thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Architect Dr. Andre, for your brilliant presentation. The title of our next presentation is In Relationship with Bamboo by our second presenter, Architect Irfan Adiwara. Now we can have the brief introduction of Architect Irfan Adiwara from Architect Enam Rabbi and Architect Riju Sarkar.
Thank you, sir. Architect Irfan Adiwara is our another speaker this evening. He is an emerging young architect from Indonesia specialized in bamboo structure design. He completed his B.Arch in 2005 from Gajah Mada University, Yogyakarta, and was an AA school visitor member since in 2011. After learning and working for a couple of architectural design firms for 11 years, Architect Irfan established his own architecture studio in 2011, namely EFF Studio. He has also established Bamboo Notion community where creative constructive ideas on design and architecture using natural materials, particularly bamboo, are encouraged. Irfan would bend, cut, and shape bamboos into some crazy-looking yet beautiful structures. He initiated this campaign to promote bamboo's usage in architecture across the country by hosting seminars in universities. He has conducted several workshops on bamboo, model making and installations with the architecture students in Java, Bali, and Yogyakarta. The rich variants of local material in Indonesia have endowed Architect Irfan with fresh ideas and creativity. His works are spread along Indonesia, including Riau Islands, West Java, Yogyakarta, Bali, Lombok, and Sulawesi. Among his works, Pemuda Rahayu Bamboo Hall, Lotus Bungalow, Almarik Restaurants, Liabech Resort are remarkable. His project, Bamboo Canning Restaurant, has won Citation Award of Future Arc Green Leadership in 2014, and the project, Dodoha Mosintuo, became a nominee for Aga Khan Award for Architecture in 2016. Let's hear from Irfan himself about his journey and the story of how he developed a unique relationship with bamboo. Ladies and gentlemen, Architect Irfan Adiwara.
There's nothing. Good evening, everybody. My name is Irfan Adiwara. There's something here. I'm an Indonesian architect. I'm based in Bali, so the party island. So there's a lot of architecture going on there. So I'm based. My parents are from Jakarta, but I decided to go to Bali for having more experience in architecture. I like to have the natural organic material, which is difficult to get in Jakarta, which is high-rise buildings. I don't really like it, so that's why I moved to Bali and then involved with this kind of architecture. Sorry. I close this boundary. And I use mine. I'm sorry. Okay. Yeah. Okay. Yeah. Sorry, my title is not that really sophisticated thing. So it is about the presentation is about story of my life with bamboo. So it's about my relationship with bamboo. It's like what you posted in your social media. Is in relationship means it's more than just knowing. Yes, you know bamboo is one thing, but then in relationship means you know the good things about bamboo. You understand the bad things or the disadvantage using bamboo, and then sometimes you need to adjust your ego and design that bamboo cannot do it, or sometimes you can push the bamboo as like with your partner in your relations, like you need to know each other, you know to adjust it. Sometimes you need to compromise things. So that's what I'm trying to tell you about what I've done with bamboo in this like more than 10 years. Yeah, I would say that this is kind of like the relationship goals, like what you have, like what we have. Love in the first case, not kiss case. Before I work with bamboo, I work with a German company making knockdown buildings, ship it everywhere in the world. So we design in Bali, we make it in Bali, modular, knockdown, ship it to everywhere. This is for Fiji. We need to build this like 10 set of the house for the resort, but we buy extra 10 for sure. Like when you have projects, you have 10, we buy spare two tents, and one being used on site, but then one still leave it at the office. So that my boss said to me like, Evan, we have one tent left, we need to use it somehow because it's just not wasting the money, just put it in the storage. Okay. Let's build the structure to hold the tent. I would say, okay, just build with this kind of structure. No, we don't have that money for that. Like this structure anyway, it is $150,000, but they just give me like $500 to solve that. So yeah, we have that tents, and then please bring that tents with no structures, and then you need to figure out with $500. That's challenged me, and then I'll go around outside the office and trying to find the solutions. But I found that's my first time to realize there is something that I can use. There's a bamboo. Then I think, okay, the bamboo is cheap enough. It is less than $1 at that time for one poles in Indonesia, in Bali. So, okay, let's use this. I buy some, and again, use our creativity. I'm trying to make a structure that's bamboo poles, like less than $1. I buy like 40 of them, try to combine it. I'm trying to erect it, and yeah, the structure, the tent is erected, become our public space in the new office. From inside also great, and we do the cross-bracing things. And the good thing is, my $500 is still have spare. So, making these kind of structures, it looks good. It's strong enough to hold the tension of the tent, and it gives me less than $500 to build. And this is 2007. Now it's about 11 years, right? And then still exists. So it's kind of strong too and durable, actually. When you protect the bamboo from the elements, from the rain, from the sun, it's strong enough and it's long lasting. At least more than 10 years now. So with this project, I get the idea, okay, I fall in love with this material. Like, this is give me answer of, but I want to be really design something that playful, but in the meantime, that's really expensive, using steel, using laminated wood, but God give me these materials like, okay, actually this everywhere in Indonesia, and I hope there's also in Bangladesh. If you put the energy, you put the creativity in there, and become something that can be works and also affordable. So this is my first case that make me I'm in love with the bamboo. So by doing that, I resigned from that company, and then I'm start learning about bamboo. And this is few characteristics of bamboo that I can find based on my experience. Bamboo is long. Actually, if you go to the forest, bamboo is at least 14 meters long. But if you see bamboo in the street, it's 3-4 meters because the truck who can bring it here, because it's really difficult to bring 14 meters. And anyway, people don't need that a lot. But actually, that's long. And bamboo is curved, so it's not cylinder. As Andrew said, it's about the conical, but it's curved. When you draw bamboo, you cannot draw bamboo straight. Bamboo is always curved. So that's the natural characteristic of the bamboo. I need to take that as a curved material, not as a straight cylinder pipe materials. And it's hollow, it makes it lightweight, and it's flexible, it's smooth, elastic, and a lot of other technical properties that Andre somehow already told about it from his presentation, which is good. And we, F Studio, I established my own my studio, committed to create the characteristic design using bamboo, but it should be only can be built by bamboo. I mean, not trying to replace other materials style, but this only can be built by bamboo, or at least effective build. Maybe can be built with the steel or other materials, but then this design is only effective cost-wise, the way it works-wise, it's only with bamboo. So that's how my studio really want to go design something with bamboo. Okay, that's another relationship goal is about the trust. This project is at the place in Sulawesi, that's another island in Indonesia that never been used bamboo before, and maybe it's good example for you guys here, like never use bamboo in the updated way. There's a project in Sulawesi, it's called Dodoha Mosintu, the one that nominated in Aga Khan Award in last cycle, but it's good. We not win, but then being nominated is also a big honor for us. The project is about orphanage. There's a conflict in that area in Sulawesi. So our clients, the NGO, want to empowering the children and the women. So we need to, they say that please make Poso with the new image, not about the terrorism, not about the conflicts, should be something. And meanwhile, also please make something that can be useful for the kids, for the women that they are empowering. But the funny thing is, like, the sites, when I see the site, where's the site? This is the site, like, yeah, this is water, so where's the site? Yeah, this is the site. So this is in the high tide. So when this low tide is going 50 meters down, but then in the high tide it's like that. Okay, so we cannot have that. They said this cyclus is about every 10 years. But I don't want to make something, buildings that drowning in every 10 years, right? So we need to think about it. But this is the site. It's really good facing the lake, one of the biggest lake in Indonesia. Again, we try to use local, so we go around checking the bamboo, because they never use it. I found their bamboo. It's not that big as what we have in Bali, but then the thickness is really good. That's my hand that's showing the thickness. And because they never use it, this is really old bamboo. It's really strong. It's comparable with the strength of the wood. So it's really good. And the good things with this client is just do whatever you want, Evan. As long as our activity is accommodated, that's really dream clients, right? So, because in that area, they never use bamboo as updated before. They just use a really basic shack or basic hut. We try to show them like what kind of bamboo can be do. Like this is the preliminary models. we give them like 15 meters span in the front as a bamboo hall. 15 meters, no columns, big spans. And then in the center there, we introduce them about the bamboo shell that will be accommodating the library for the kids. And we also give them like 3-story design that show them that bamboo actually can be 3-story. So this is the actual structural design that we designed. So we put extra land a little bit, just make sure that the library is not drowning by the high tide. But then the floor of the hall, we use their boat, their natural boat, their wooden boat, so they can float and they're going up and down, while the structure is like hanging around 15 meters to the lake. It's a funny thing that when we bring the models there and people say, and the kids say that, you bring toys. It's not a toys, this will be the building that you will have. The challenge is like all the carpenters say that, what kind of building is this? It's difficult to make. Let's make together. So I bring few experts from Bali and then invite all the carpenters who want to learn and working together with us. So this is how the construction is happening when the low tide for sure. So we have the retaining wall, we have the foundations in the middle of the lake, and then we start to join the bamboo. And that's how the works. And so this is when they're done. This is in the high tide again. For sure, it's not that really clean, perfect look as what we have in Bali, but then built by only 4 Balinese workers with come and go 40 carpenters doing that kind of structures. It's still amazing for us. And this is the structure also from when the high tides. And this is about the 3-story office for the NGO. We try to also accommodate using local roof, which is they said it's not cool anymore, but then when we design something like this, they start to believe, actually this grass roof is great. Yeah, if you know how to use it, and if you're creative enough to tweak the design of it. And this is the library. We put the skylight in there, so make sure that the sunlight's coming in, and this is the body tree. That's the Buddhist body tree. Somehow there's there. We're not planning to plant there, but then in the side they have there. So it blessed. It's the tree of knowledge in the middle of the library. So it's really perfect. And it grows because of the skylight. You get the sunlight and they always put the waters and shit, so it's grown. It's nice. And this is the office for the NGO. And this is the hall for the kids, have dance lessons and stuff. So no more terrorism. So people come together there, having fun, having a great fun. And then we also introduce water is the front. So mostly in Indonesia, water is behind. So they throw the trash going to the water. So we try to rotate the orientations. The main entrance is from the lake, so they need to have the boat. They need to live up again the boat, the lake livelihoods. So mostly a lot of boats coming around. But they still have back access. But then by having this entrance, they feel again the magic of the lake. And even like we have the nominated by Aga Khan Award. But then I think the best award is this face from the kids, that they're really happy with the buildings. They're really excited. They want to learn something new, and mostly before they don't want to go to study because of this building. They want to come there, and then together with the volunteers, they'll study about English, study about math and something. So this is our big reward. And for the people now in Poso, that after this building, they start to believe and start continue simple things for their garage, for their chicken cage, even they make some furniture now with bamboo. So before they just burn the bamboo, but because of this architecture, these buildings, they start to actually they have something in their backyard but they try to save the money to buy concrete and steel from other city, but actually they have something in the backyard, and if they creative enough, they can build something good. That's simple. So that's another thing, that prepare for unexpected. Yes, and our relationship, sometimes we expect it being smooth, but sometimes something's not unexpected happen. And this happened with our projects in Gili Trawangan. There's another party island, more party than Bali. That's in Lombok, close by. My client, yeah, this island, so no cars, no motorcycles, so it's green, but then all parties, so all drunks, there are people there. But every hotels, they want to make some beach bar, try to be unique every of them, so trying to be competing. So they asked me to, Evan, please design something different with bamboo. Okay, I go there and I check around. So mostly this kind of structure, I would say, okay, yeah, we can face it easily. But the next thing is this one. It's not designed by us, but it's already done, and it's great. And it shocked me, like, oh, okay, somebody already did it. So what should I do? And even it's not only one, there's another one. This is also nice waving bamboo things, like, okay, so should we cancel the project or something? So sometimes this is unexpected. We think that we are the number one in Bali, or we are the top front designing something creative, but somebody did it. And if we did something like that, people would think, F Studio only followers following these things. Sometimes our ego is, you cannot, I don't want to follow everybody, right? So, but here we are architects, sometimes you have really stuck with ideas. I don't know, you have that experience, or only me? But I'm trying to get different ideas of what they already have in their islands, but should be functional, should be authentic, but should be different, should be follow the rules. Because the rules is actually, you should be lightweight structures in the beach area. So it's not having any solid structure, because it's in beach area, should be semi-permanent structure. So that stuck me. The clients always calling me, like, I need to extend the deadline until like another month. I said, okay, we don't get the projects. But then one time, sometimes the ideas come not from the architecture things. So in one night, I almost give up. Okay, I need to go to bed. I want to go to bed. I see something under my table, and that's the magic there, actually. That's inspired me to create a proposal for these projects. I saw my flip-flops. This is not real my flip-flops. Mine is worse than this one. This is the new one. But then, actually, I want to go bed, and I check my table, like, this kind of structure, right? You know, that's columns with the two arches around, and if we think that the columns with the round table bar and people's eating there, and with no columns, series of columns, so no view will be protected by the columns, or full view with this kind of structures. So the mind is still developing. So I'm start making sketches, so I'm not going to bed, and this is kind of like idea. Sorry, my bad sketch, but then, yeah, this is the idea. So there's the flip-flops main structures with the dining hall will be there. There will be the bar in that pointing columns. We make the model again like that with the space frame, but then organic space frames. This from the front. And then we put the tent compared to the others like natural materials, because then we try to be different, while also it's lightweight structures that we tent. And then, yeah, this is model about the bar, but the other sides, and we did the structures. And the clients choose, okay, blue instead of white. Okay, that's the client's choice. Actually, I'm not really like the blue one, but then again, the clients want to have the blue. It's striking from from farther from the islands, and already, oh, blue, that's the new bamboo buildings. But the challenge, like, we have these structures, but then, like, the tent is capture the wind. We just worried when the wind blows from the oceans, blow this up, and this is really lightweight, and then this just maybe going up. So we need to think smart about that. So what we designed, we modified the middle tent with the layers of sails, inspired by the sails of the boat for sure, and then it gives segmental feelings from underneath, but also give the wind flows, so the building is still safe there. So this is when it's done. This is the bar. This is the bar from the other side. And this is from the ocean. So when people eat there, it's not bothering by any columns. So a lot of people come to this beach bar because of that. So they have like more than 180 views. And lucky, after that, there's an exhibition of Indonesian architecture in Frankfurt, Germany, and then somehow, because that building is very unique, we've chosen, become one of the 15 chosen architects in Indonesia to exhibit in Frankfurt. And this is actually the Manfred Grohmann from the Bollinger and Grohmann is the competitor of Arup and other things that they really like to help us to calculate the structures, and they offer us like, every design that you make, please give it to us and we will calculate. I just said, I just cannot afford you guys. It's really expensive, right? And our project is really small. But then these guys are really interested with our small studio works. That's really amazing. That appreciated by them. And then, become one of the 15 architects in Indonesia because of the stock ideas. It's good word, and it's one of the 15 guys there. There's all the famous architect in Indonesia, but not building with bamboo. Only one, me in bamboo there. Okay, that's about the flip-flop buildings. The other goal is about the solid and strong. You need to make something solid and strong while facing something happen in the front. We make a wedding chapel there. In Bali, there's a lot of wedding chapel. Again, they want to have unique things. It should be different than other wedding chapels. There's in Candidasa, in East Bali. But the challenge is the space they give us is really tiny. Only 8 meters width and 15 meters long. So in that middle between the palm trees. But again, we need to think creative about that, using bamboo. The chapel mostly triangular, and triangular is the really solid structures. But it's not that really basic triangular, but we just follow the shape of the bamboo when we're making triangular. So basically the shape is like that, but then we follow the curve of the bamboo and we just connect them like this. And to connect each of them like that, it's strong enough. When you have a tie beam underneath, that's perfect triangular. And the design is like this, actually facing the oceans. The good thing with bamboo, because it's considered semi-permanent, we can really go to the edge of the retaining wall, which is other building materials cannot be done. And because the spectators, there's a waiting people, and then there's the family and stuff. My client said that we need to see each other side, not just like in the triangular. Okay, then we make a series of glass, which is have gaps between of them to make sure that when the wind blows from the sea, it's spread. It's not just like wind tunnel and everybody will get sick about it. And this is a structure, so it's really simple, really fast. Just grab the bamboo, whatever we have, making triangular. And we try to be some creativity here, like the rafters mostly like vertical, right? But we try to be how if the rafters horizontal, and again following the shape of the bamboo. And we use the small bamboo that people never used it before. Like people just throw this kind of bamboo away. We use that because we know, and the distance of the rafter we can play around. No need to be exactly same. So this is really tight and then going that spread out like this. This is really good for the interior. So this happened, and then yeah, this is the glass. We make a custom glass. The glassman really mad to me because it's difficult to install this one. But yeah, when it's done, like this, we use the flattened bamboo roof. And this is from the oceans. So the glass is really look nice, compositions wise with the bamboo. And even yeah, we not only going to the retaining wall, we offer the retaining wall there. So, and it's okay because of the semi-permanent buildings. And this is the interiors when we don't have any furniture yet, with a simple colored bamboo with the lights, and then this is the night. So in the night, if there's no wedding, they become the lounge of the hotels. So simple, triangular, but strong. And again, the others is compromise. If you do good thing in the small one, maybe you will get the bigger one. So that's happened with us. The chapel is the small thing, and then the restaurant, the resorts ask us, okay, you're doing good with the chapel, then let's renovate our restaurants. It's bigger than, yeah, this is the old restaurants, really old building. It's built in 1980 something. So, and this is the entrance of the resort. It's nothing catchy. So we need to have something that identity of this resort. This is the plan. They're categorized. They have the C categorized because of their bad reputation, not reputation, but then the bad service. Why? Because that's the center area that I put the hatch. Actually, that's for the rest of the employee. So that's the kitchen, that's the employee rooms. So when there's no guests, they sitting around in the middle. While the guests come to the lobby and then go down with the small alley going to the restaurant. So like, how come this happened for that long time? So we need to design, we need to compromise. And I say to them like, okay, guys, when you work there. When you off, you go to your rooms, then this the other rooms. So we divide the plan with that. So when people come, they directly see the restaurants and see the view. Then our clients trying to keep the building existing as much as you can. So okay, we maybe just take out the roof. And then what kind of ideas? Their logo is Mantarai. So this is, we think, okay, how if we make something like this? It's fit with the, so that's the cardboard is the existing wall they have. We just put the Mantarai on it. On the top, that's 15 meters span of octagon. And we put a little bit, squid tails in the back for the kitchen and the staff rooms. This is kind of sections, the details. But that's how will be the look. It's like Mantarai, octopus, Squidwards, something like that. Yeah, this is me. Can you guess this? What is that? This is not the archery. This is the model of the truss of that Mantarai ribs. So we do a little bit parametric, but then manually like that. So using that model, so our workers is working with that models to replicate that. And this what happened, the structures. We put the bamboo weaving as a ceiling. And we do this above the kitchen, so the heat at the kitchen is going out, while also making creative ceilings instead of just flat. And that's from the top. We put the asphalt shingle on it. And I think we have a good proportion of the openings there. So bring lights in, bring the hot air out. And yeah, this is the entrance now. They got the fillings with the glass, skylight. That's the interior that I think you guys use it for the posters. That's from the inside. Yeah, so basically we kept the wall, but just we put another roof on the top, and it works. Sometimes you need to compromise with the concrete, sometimes you need to compromise with the others, but then should be fit together, so the end of the design should be really nice. And this is another thing, like just the way you are, just don't try to change it, don't try to change your partner, just love the way they are. So we try to also just love the way bamboo are. Okay, this is the model from the top, but actually, this is a project in Jogja, in Java. There's a lady have a flat land, but close by the river. There's a cliff, it's about 14 meters deep. And you can guess that she decided to design the constructions. I want to have the house at the cliff. Yeah, but you have the big flat land. No, I want to have the cliff. Okay, challenge accepted, because only bamboo can do that because it's really lightweight. So it's okay, compromised by the government because the weight is almost like 1/3 of the concrete or the wooden structure. So it allows us to build on the cliff, so it's not causing the landslide. So this is the idea. That's the cliff, and we try to make a compound of the house because there's a tree there. So we make a tree compound of the house. What I mean of just the way you are is like I said in the beginning that the bamboo is long. So try to use that as a bamboo, as a long bamboo. We use this 17 meters long bamboo. We not join it. But luckily there's next to the site there's a bamboo clumps, a lot of bamboo clumps. So we just take from there. We do the treatment on site, and we use it in the constructions. So that's in the front is 17 meters long bamboo. We're not cutting, so it's really pure, like 17 meters, and then it's going small. So the idea is like this: from the flat land, the owner will come to the second floor, going to first floor, going to the ground, and going to the river. That's the idea. So this, that's something like that. So we have one in the middle is the tallest one. So the third floor, second floor, first floor, and then going to the river. And this is how the complicated foundations. We try to not changing the contour of the land. So we are following the land. So the foundations, the tie beam is following the land. It's like grabbing the contour. It's kind of like spider web thing. While after this, the bamboo sit on it. My engineer said that by doing this, we're not ruining any existing contour that has been there for a couple years, like maybe 40 years or something. So basically, then if we cut the hill and we don't using retaining wall, there will be landslide. But we don't want to have retaining wall because that will be expensive, 14 meters, and not looks organic. We use that, and then we put the bamboo on the top of the tie beams there. So again, this is like another replication of bamboo clumps there. So it's 14 meters, 17 meters, and then going to 14, going to 10, going to others, and this is from the top. So when people arriving there, only one story, but then when you go down, okay, that's going down until to the ground. And then the structures went on the half of constructions, and we keep the trees around it, so it's become like really in the middle of forest and sitting perfectly there. And this is when it's done. Forget it, my friend there, because he just want to say that. But yeah, the idea is like we use the same bamboo roof with the really steep angles, so the waters go run directly down. So, and we put the little bit skylights there, so every floor they get the lights coming. It's perfect, and it's everybody like that, and it's fit with the sides. Another thing is like sometimes in a relationship you have complicated, but you try to work it out, right? So this also happened with our projects with the bamboo. It's complicated from the clients for sure. They want to make something like this. It's it's not like what Andre have, which is like more parametric things. They just give me 3D. Also like 3D, you can do it, anything. But then with the bamboo, like, another thing. So sometimes architect just, Evan, please make it works. Okay. But yeah, this is another challenge, and because nowadays a lot of people using the parametric idea, we try to, okay, let's update it to that level. We can do that. And we make the models again. That's really, I need to learn about how the grasshopper, the rhinoceros things, and then, but suddenly, yeah, we still do it manually. We make the models like that, or actually how it twisted. And yeah, and the challenge is like to explain that rhinoceros models to the labor with never known about the parametric, but then, yeah, step by step. I'm every single day need to be there to make sure that they understand how the twisting bamboo things. But yeah, it's 1.5 months to construct this. And even the clients want to have extra extension out, so it's not just perfectly round, but then extension out, even more complicated, but then it's done it. This is almost done, and then this is done. So this is actually for the Westin Resort in Ubud. The resort is okay, but because of this, people like to come just for selfie with this structure in the lobby. Sometimes we're not doing the great things in the projects, but then we try to make something that stating things. Like their design is really typical standard hotels in Bali, but then when they have this in the lobby, that makes the image of the resort different. So we love to make something like that. And this parametric, yeah, we can update it too with this kind of design. And the good thing is with relationship, we try to not egoist, become only you and your partners, but we try to be benefits to the others. So that's what we done when the Bamboo Notion said in the beginning, said that we also having Bamboo Notion. Bamboo Notion is about learning process. We invite learning process with the students, with the people, with architects, with carpenters, as what Andre have, but I'm not that much as Andre, but then we have this one sample in 2014 with the Sydney University and my alma mater in Yogyakarta. It's 3 weeks, 1 week in Bali and 2 weeks in Jogja. We try to build something to be understand about bamboo, try to love bamboo. Yeah, we, same as what Andre said, that's mixed Indonesian and Australians making together. But my main brief is just, we're not just making something, trust, take a photo and then throw it away. So we need to make something, when we have workshop, we need to make something done and functional. So we try to make our workshop is more, you will feel always about the workshops. So our brief at making cover for the motorcycle park in the campus is 17 meters long. So these kind of models they try to make. And they are also making simple structures there by themselves. So shelter, unique shelter. So they design and then we decide which one who win the design and then they start to build by themselves. And it works. And then this is the main structure, 17 meters. Built by 60 students, 30 from Indonesia, 30 from Sydney, and only assist with 3 bamboo laborers, but they only assist, they're not working, but just like doing this, doing that. So this is what we're trying to do in F Studio. We believe that working together still become one of the solutions making architecture. So here in Indonesia for 19-something, they move to the roof, the house together. We make some simple workshop there for the gate for the village in 2013. That's in the 2014 in Jogja, and then we make a tower in 2014. So we try to also introduce that with our power, no need to be with the electric tools or big machines. Big machines, they can be erected simple, maybe 10 minutes, but then these kind of structures, they erected like 30 people working together. Like we try to lift that up again because now we are more in individual way. We try to collaborations. And the next steps actually we try to build something. Like we have case here. I don't know you have that kind of case, but we are in Indonesia. Like these kids want to go to school, they need to be a circus player, like in the cables like that. That's dangerous. But while I have experience building design something like this, why we not? And we have the workshop that almost like a bridge too. So in the future, we want to make a workshop like this. Even like we try to open the design competitions of bamboo bridge, so and it can be applicable in anywhere around the world. So that's our dream next. That's the thing, and I just want to show you the video. Gone. This one? Okay. Okay. Maybe lower the volume. It's not need to be. Okay. Okay. That's the workshop for the artists, as you know how we working on it. So we make a templates on the ground, making the curve, using only small bamboo. No big machines, all by hands. Yeah, even this funny way they make a holes, but they're students as well. Try to make the bamboo nails, pipes. That's how we join the bamboo to become that length. And that's how they bend the bamboo. Yeah, that's their own design. They build by themselves. Shelter that still exists until now. Manually connected. Thank you. We hope that we can do it in Bangladesh someday. Thank you. This is my presentation. Right.
Thanks a lot. Architect Irfan Adiwara for your wonderful presentation. For panel discussion, we have two eminent architects, Architect Bashirul Haq and Architect Nahas Ahmed Khalil, who have vast experience of designing with local materials. Now, may I request Dr. Andre, Dr. Irfan, Architect Nahas Ahmed Khalil, Architect Bashirul Haq, Architect Qazi Ghulam Nasir, Architect Qazi Arif, and Mr. Tamal K. Shaha to kindly come on the stage. Now I am requesting Architect Qazi Arif, Secretary IAB, to moderate the panel discussion part. Architect Qazi Arif.
Thank you very much, Dr. Shehzad Zahir. I think most of us are really astonished and sort of excited to have seen and experienced such wonderful presentations by our two invited speakers who have traveled all the way from Indonesia to be here this evening. So first of all, I must thank both of the speakers for your wonderful presentations. And we have two eminent architects, member of our community, who are here this evening with our invitations to kind of discuss on the presentations and sort of analyze their presentation in the light of the practice and pedagogy in the fields of architecture of Bangladesh. May I start with Architect Nahas Khalil to shed some lights and thoughts on the two presentations we have just experienced. Architect Nahas Khalil.
Thank you. I thank IAB and Kohler for arranging this occasion. I feel very fortunate to have witnessed this because with every newly emerging material, there's a turmoil in the existing status quo, and after the turmoil has settled, we get something new, fresh, and wonderful. So we've seen the beginnings of the wonderful work which these two people are doing. The work on bamboo has started quite a few years from now. I think Colombia is leading one part of that work. We have seen Anna Heringer working here with bamboo, and she really hit the hammer on our heads with that. So, but that's a start. But the reason I say I'm fortunate is because this combination of somebody working hands-on with the bamboo on an at an intuitive level, and somebody who is at the same time working on the engineering, which really makes the material more part of the larger industry. So in one sitting, we've been able to see both of them and their work, which I think is rare. And I'm missing all my engineering friends who should have been here to see this. So I propose that we try to expose them to this way of thinking where Architect Andre, I'm not sure whether he's an engineer or an architect, but I feel he's more, his mind, I was um, very impressed to see that his deep understanding of the material of bamboo and the wonderful marriage that he has achieved by the understanding of engineering in the structure, engineering concepts. So I think it's rare for an architect to have the engineering concepts, and he understands that, and he marries that with the aesthetics, and his understanding of bamboo, the material, puts him in a place where he can take this whole activity to a level where if only an architect was working with it, couldn't have achieved, or only an engineer working on this couldn't have achieved. So I think this is a very unique situation. I think the world should be grateful that this mind came together in his being, and that we will be beneficiary of this. Whoever wants to practice or take part in this activity will benefit from the way he has thought out the structure. So that's the part I was trying to say, that I'm very fortunate to have been here. His concept of engineering of this, I'm not very familiar with this, but I was this was new to me. Transegrity, reciprocal tension, and rection is your term of doing it. So is this also done in other materials, the same concepts? Is it existing in the engineering jargon? These three things: transegrity, reciprocal tension, and rection, particularly rection. You are using bamboo for doing this, but is it done with posts, poles, metals, the same system? Or is it?
I think the system is like can be used with other materials.
But is it practice?
Yes, yes.
Okay.
Basically, only combining the hard materials, which can be bamboo poles, can be steel, can be aluminum, combined with flexible materials which can bear the tension strength, like steel wire or ropes or other materials.
Wonderful. So we have a big difference. Architects don't know anything about this. Engineers know about this, but don't know about the aesthetics. So that's what I was getting at. I'll come to Irfan's work. We had a workshop on rammed earth. Martin Rock came. So 60 architects worked on the workshop hands-on. But it fizzled out. So there's some activity going on, but I'm sure none of the 60 architects ever have built many rammed earth structures, though it was beautiful and we appreciated it at that time. So it takes a person like Irfan, I think, to take this forward, to go hands-on and work the tedium or he's not afraid to go with the new material. So his forms and the material is in the foremost. The other part, which scares us, does not hold him back. So I really appreciated that. Thank you, both of you, for your wonderful presentation. I'll hand it over to Arif.
Yeah, thank you very much, Architect Nahas Khalil, for your intuitive and analytical views on the presentations. We'll come back and open the floor for general discussion. Before that, can I request Architect Bashirul Haq to say a few words about the presentations?
I will start with thanking you profusely for a very wonderful presentation. As a Bangladeshi, I'm used to bamboo houses, which are primarily rural architecture. Over there, the bamboo use is very rudimentary way of vernacular architectural work. We have not taken, as architects, bamboo as a building material the way you have taken it up. I feel there is a lot of interest among young architects, particularly when they're designing in the rural areas, to use bamboo as a building material. It's going to come, but I think your presentation will give them a boost of the way bamboo can be used. As a kind of an architect, my problem was when I looked at the way you use bamboo as if bamboo is a metal, which I find intellectually a little disturbing. Is bamboo a metallic material? Bamboo characteristically, how I know engineering wise probably there is no problem the way you have detailed it out, the way you used it. But inherently a material has its own characteristic, like brick has its own characteristics, concrete has its own characteristics, metal has its own characteristics. When I'm using bamboo, shall I make it look like as if you can do anything with that material? Now, in your defense, I would like to cite, before the Greek architecture, they started building with stone. They used to have wooden structure. What happened in the beginning is the stone structure was replication of wooden buildings. What I think, it is now going through that phase. A phase will come when stone buildings or concrete buildings, the way they have evolved, bamboo will evolve the same way. So from that point of view, in your defense, I would say that the way you are using bamboo at the moment is you are using it like other materials, like steel. So maybe we should really understand the inherent characteristics of bamboo and use it the way bamboo should be used. But again, I have to profusely congratulate you for a really wonderful way that you've shown us how bamboo can be used. It's in progression. It will evolve. It will probably come to a sophistication the way brick has come to a sophistication or concrete has come to a sophistication. And I am particularly interested for the young architects in this country to use organic materials for building, because that's probably the only way we can save this earth by being, by not destroying the environment of ours. So it's in a way, bamboo is probably the less destructive material to environment. It takes less energy to grow, and so thank you so much for this.
Thank you very much, Architect Bashirul Haq, for your valuable comments. Now I think we can open the floor and take a few questions to the speakers and also to the invited discussants. Can we have the lights of the audience turned on, please? And I'm sure there are a couple of volunteers with a cordless microphone. If someone wants to ask a question, please look for the volunteer and ask the question with your name, please. While we are getting ready for that, I have a question for any one of you. The question is, do you have any study on the lifespan of these kind of bamboo structures that you are building? We can calculate lifespan for concrete structures, brick structures, but for bamboo structures in this contemporary world, do you have a calculation or anticipation of a lifespan?
I'm not doing the calculations, I'm mostly based on my experience. But then the logic is like this. There's a sample, like in Indonesia too, I think in other country also. There's a bamboo constructions that last until 100 years. Why? Because choosing the materials in a good way. They choose the mature bamboo and they treat the bamboo good. And also the design is good, so it's not giving a really overload to the constructions, and it's protected from the elements, sun, rain, and other stuff. So theoretically, it can be less until 100 years. But for sure, our design in F Studio is trying to update it, try to explore more about that. So we try to be less columns, but again, we discuss with the engineers. So we try to keep the point that the designs are also still good, while we also maintain how to harvest the bamboo in good, treatment the bamboo good. So I believe our construction could be more than 50 or 100. But then professionally, and as the architects who have experience only about 10 years plus a little bit. So being said as bamboo will last at least 20 years could be reasonable now. And for clients, okay, what years you have experience? 10 years, but then I say 20 years, okay. And because I can show my clients that the bamboo that we built in 2008 still exists until now and no damage at all. So we believe that the next 10 years should be fine. But then again, the next 30 years will be fine, or the next 70 years will be fine, as long as we have the maintenance. But then as theoretically calculations, I never done that. But just that belief and that proof, I'm trying to convince the clients.
Sure, sure.
You see, the building life cycle is the amortization of the building. Like in the States, they take the life is 20 years, repayment now. So, but in bamboo's case, you meaning not life cycle, but the sustainability, or whether it is going to remain in a good form for years. The studies have shown that bamboo lifespan, not amortization, is about 18 years.
18?
1/8. Provided it's properly treated. Untreated bamboo life is hardly 3 years. But it could be 18 or 25. But for amortization, building life built with bamboo is going to be much less. Because if you want to take a loan from a bank, they will not amortize for 20 years. They will amortize for 10 years. Things like that.
You want to add anything, Henry? No, asking him.
Okay, I don't have also the experience on the durability of bamboo, but as far as I know, the first bamboo construction that I've built in the end of 1999, or let's say 2000, I built the plastic bamboo construction. Up to now, it's still in the good condition. So it is already 18 years. Yeah. So I do agree that first we have to use the preserved bamboo, and the second is we have to make a protection by design. Yeah. Simon Vélez said three principles: big head, high heels, and good air ventilation. So with this preserved bamboo and this preservation by design, we can expect it, the bamboo construction will last very long. And according to a friend of mine from Colombia, he said that there was still a house out of bamboo that was built 200 years ago. So it's probably also good news for us that we can reliable on these materials also.
Thank you, Henry. Now, anyone from the audience? Yes, Professor Haruna Rashid, please.
I'm Haruna Rashid. It's not a question as such. It's supplementing what Mr. Bashirullah said. In my own village home, I have a bamboo structure that is about 70 years old. In my grandmother's house, there's a structure that's over 100 years old. As you rightly said, it has to be protected from the rains and from the sun, and use good quality bamboo and with some treatment. I think if you do that, it will. And amortization is something very different. Durability and amortization is very different things.
Can I just add one more thing? When we think of concrete, when concrete was first used, I think the span was given as 50 years or something. So we have concrete which is more than that, because concrete has been that old. But also think about that there's a huge book, big fat book in Chandigarh. It's how to conserve and repair Corbusier's concrete. So if we think that we make a building and you do nothing to it, then the lifespan will be bad. If you keep maintaining it, I think it's quite a safe material. So we have to think that, taking that into account as well. That there will be maintenance, there will be period maintenance, that there will be some parts which has to be replaced. Anna's building, there's some replacement going on, but that does not take the life cycle down of the material itself. It's how you construct the building.
I have a question. I'm architect Fawad Haider. I want to know how do you curve the bamboos? I've seen a lot of curves there. This is one question, and another question is what kind of cladding materials on the roof you use? What do you use on the roof or the walls? Exactly. Thank you.
Okay. As I said in the presentations, that the bamboo actually is not straight. If you go to the forest, most of the bamboo actually curve. I think what happened here in Bangladesh, in Dhaka, and in Indonesia is almost the same. Like people try to sell the straight bamboo. They choose in the forest, they try to get the straight one, which is actually a lot more the curved one. If we're not going to the forest, we will not really see that actually a lot more the curved one. So what we have to do, we go to the forest, we ask the bamboo man, like, okay, mostly they try to get the straight one, and they cut the curved one and they just throw it away. How if we buy in half price? So it's not wasting for them. It's not wasting for them, it's good for us. And we create something like that, and the value is really going up. So actually, we should keep in our mind that the bamboo actually curved, or even it's not really curved, then we can still bend it. It's flexible. But while you bend it, it's not going backwards. We try to slice the bamboo a little bit. As you see in the video, like the students is try to slice. It's not all the way, but like 1/3 of the diameter. So it start maintaining the bend. And when we slice it, we need to have at least 3 bamboo combined together, not only one, because we reducing the strength of the bamboo. That's why when you see that, at least I have like, it's in 2, but actually there's another one behind. So like 3 bamboo together become like that kind of bend. So that's how we bend the bamboo. Actually, we try to buy the curved bamboo, and then if the curve is not that what we need, still need more adjustment, then we try to slice them. If it's not, like the one in the cliff, that's no bend at all. That's all the bamboo 17 meters. It's naturally will bend like that. So that's how the curved bamboo happen.
Okay, thank you. Architect Ishtiaq Johir.
I'm Ishtiaq. Thank you very much for this wonderful presentation. I made a last time registration, and I think that's a wonderful thing happened. My question to both of you, how do you see bamboo as a design material, not as a construction material? I'd like to see as a design material, as a mainstream architecture in near future, because what United Nations, UN Habitat has declared that next decade is a decade of sustainability. And in our global south, Latin America, where Colombia we've been talking, and obviously Indonesia, Malaysia, as well as Cambodia, even in Vietnam, as well as in Bangladesh, we've been using bamboo, but bamboo has always been on the side stream. Even in Japan, until Kengo Kuma or Shigeru Ban, they've used the bamboo. Nobody wanted it as an old material, not a design element, like some people ask, even brick in Bangladesh considered to be an old material. So how do you see in near future that bamboo to be in mainstream in the design field?
Okay. Before that, I answer the questions that for the roof, right? I'm not answering. Yeah, we have a lot of options for the roof, but just make sure that if you use natural roof, the angle should be really good, so it's not make the roof material rotten fast. If like natural material like bamboo flatten or the grass, something at least 45 degrees, for example. But then nowadays we have the asphalt shingles, that the one that this one, the roof for these structures, this can be a little bit shallow, the angles, and it's 100% not leaking if they install it right, but it's a little bit artificial. But as this is really in the top high, we not really see it, so we use that. But for the design that we showing the roof and people can touch the roof, we mostly trying to not use that asphalt because it looks artificial. But it works well with the curve that we designed because it's flexible. Yeah, and we F Studio trying to develop the roof tiles with the terracotta, which can also be that thing. So we will have different module that will be cool, but then it's a lot of research and a lot of trial and error. We still not release it that because it is still leaking somehow. But that will be interesting with the roof tile, but then like that. That's our goal. And about the questions about what we see in the future, I don't know, I hope I get your questions. I see by making like what we've done, people will start thinking there's a possibility, there's alternative materials. We're not saying that all can be beat by bamboo or bamboo is number one. No, we just trying to make the bamboo as equal as other materials become alternative. So architects, designers, furniture designers, product designers, they have options. There's, actually bamboo can be like this. Actually, if I want to make something like that, can be used bamboo rather than steel. But people can still combining steel with bamboo, still concrete with bamboo. That what we have done now, we combine that. We try to be one step ahead, not only pure bamboo, but then a few of our design now combined with steel structures in some parts, combined with brick structures. And yeah, I think it's about the equality and alternative to the people. So that's how we use bamboo. And I believe with that, a lot of designers trying to use that and more variety will come up because a lot of creative people, we just one or two of them. So we create something like this. But I believe even like from one of you, if you touch the bamboo and feel it, and then I believe there's new ideas of structures, new ideas of design things. Oh, actually this bamboo can be like that, which we might never think of. So what we're trying to do, like we give you ideas, like kind of like fire. Okay, guys, what we can do there. We challenge you if you can do more than us, something like that.
Okay, it's a very tough question. Probably I would not say about the future of bamboo, but I would like my expectation about the people think about bamboo. I would prefer to say that I hope that in the future more people want to use bamboo for anything they can make out of bamboo, any kind, because if we change, for example, if we change other material with bamboo, at least we reduce the cost of the material. At least we can reduce the pollution to the environment by changing, for example, the steel with bamboo. And don't think too much about the durability of bamboo. Why? Why should we build the house for 1,000 years, for 100 years? There will be out of date. There will be, the function is not relevant anymore. Just build with bamboo, whatever possible, because when we build the bamboo, the more people will grow the bamboo, and then will absorb the pollution from the air, from the soil, absorb also the CO2, because it's zero emission. This is the way I think about the future of bamboo. And now I really agree that somebody said that suddenly everything is made of bamboo. Everything is made of bamboo. Even now I use the shock made of bamboo fiber. I have a watch also, not used today, out of bamboo. Suddenly everything is made of bamboo, and I'm really happy about that. So I hope the future everything is made of bamboo also, because it's less pollute the environment. Thank you.
Thank you. Thank you.
Thank you, Henry. I think we need to wrap up this event. It's already getting too late. I'm sure you two architects are so much in love with bamboo. Your nation would turn into a bamboo nation from bamboo notion, I believe, someday. And I'm sure architects in Bangladesh also have great passion with indigenous material, and bamboo is, of course, one of them. So before wrapping it up, I have one last question to our discussants regarding practice of architecture in Bangladesh with bamboo, because we have been seeing interest growing up with architecture with the support of bamboo, especially after this Rudrapur school by Anna. But there are not being too many in numbers, this architecture with bamboo. So if you could shed some lights on the potential and the challenges of architecture with bamboo. You have 2 minutes each, I guess.
Okay. When steel section was made, nobody could have predicted that steel would be so extensively used in building, because architects use materials that are available. Bamboo is available. Steel section was made, it was available. Architects was not interested at that point. So it's a question of number of things. One is the acceptance of bamboo as the material, building materials. The awareness level of people in a country has to be such that it is time that we have to use organic materials to build. Otherwise, our own existence will be in question. So it is very difficult to predict how bamboo is going to be used. They are actually exploring the possibilities of bamboo, how it can be used. They believe in it because from reasons of environment maybe. You believe in that. And there are people who start believing in that also. These are the people who are their clients. People who believe that our future is on the basis of material use which are organic, which has not used tremendous amount of energy to produce, like aluminum. And countries like Belgium now, they have stopped using aluminum. They have extruded plastic window. ওরা কিন্তু অ্যালুমিনিয়াম বন্ধ করে দিয়েছে totally. So I think bamboo has a future in the sense that there is a tremendous interest among architects, especially young architects. Like, I was telling this story. I teach part-time at Asia Pacific and 201, the beginning of design. So I thought, let them understand what are we. So I don't think you design in your own village a vacation home. 50% of them use bamboo as the basic material. 50% use bamboo, and one of them did as much research. It's very easy. You can download information to show how she is going to build that bamboo house. So there is interest. And if there is interest, Anna, for example, designed a bamboo house which got Aga Khan Award. So you can reach to that level by using a material like bamboo. So it probably days for organic. I'm not specifically saying bamboo, but I would say future is building with organic materials, not inorganic materials.
Thank you, sir. Now, Architect Nahas Khalil.
I think the material has to find its way into the mainstream industry first. So when engineering is taught in engineering schools, they teach you about steel buildings, they teach you about concrete buildings, they teach you about brick buildings, maybe stretch structures. So that should, when it finds its way into the industry, so they'll be taught about bamboo also. And you can't say an architect is a bamboo architect. Khan was not a concrete architect or a brick architect, but you see his wonderful creation around you. So the material becomes a tool which you use for a specific solution. So bamboo will, I hope someday, it has all the potentials of becoming one. If it finds its way into the industry, then there will be creative architects working with bamboo in ways we cannot even imagine. Who would think when concrete was invented, Zahadi is going to be building concrete buildings like this?
Thank you, Architect Nahas Khalil. Now, we really are close to the end of this discussion session, and I would request Dr. Shehzad Zohir to conduct the rest of the evening's event. Thank you.
Now we can move to the next part, felicitations. In this part, Kohler's Vice President, Mr. Tamal Keshaha, will present books among who are present in the stage. First is...
Yeah, before I present, this is basically, I'm from Kohler, Tamal Kanti Shaha. I take care of the South Asian market, sales and strategy planning. I would like to say a few words about this evening, if I may. Huh? Oh, okay. So let me just...
First, you can present the publication among the invited speakers, Architect Dr. Andre, then Architect Irfan Adiwara, Now the honorable discussants, Architect Nas Ahmed Khalil, and Architect Bashirul Haq. And now the turn of IAB President, Architect Kazi Ghulam Nasir, and Architect Kazi Arif. And now the time to deliver crest to the honorable discussants, Architect Bashir Haq from the President. Yes. Architect Bashirul Haq. And Architect Nas Ahmed Khalil. And then to the speaker, Dr. Andre. And second speaker, Architect Irfan. And to Kohler Vice President, Architect Tamal Keshaha. Now, Mr. Tamal Keshaha, you can say a few words.
Thank you. Basically, I was in double minds when I was coming and I was talking, what kind of subject and topic is this? And if we may say Bangla Bash, right, it has double meanings. But I am really amazed by seeing both the presentation, and it actually reflected the opportunities, the probability, and the possibility. And when both of you are presenting, I was going through that, and I was not missing the Argentina versus France match, but I was so much into your presentation, and it was like left brain and right brain in play. When Dr. Andre, you were speaking, and I fully agree with you, totally right brain into this thing, and we are thinking that can bamboo replace steel? And when you are talking about, I was thinking like love at first kiss, what kind of lead brain phenomena is coming, and it is fantastic. And I'm really happy about this association, and I think it is the first opportunity which we got. And when I was standing in the beginning in the outside with যদি তোর ডাক শুনে কেউ না আসে or গ্রাম ছাড়া ওই রাঙামাটির পথ and this breeze and বৃষ্টির গন্ধ, and was taking me back to Shantiniketan or Shilaidaho. And the same way, the way we, Kohler Company, we started around 145 years back in 1873. The world's first bathtub was created by the great-grandfather of our current chairman. Again, from innovation, it was basically a water trough from where the horses used to drink water. And he, in a foundry, covered with enamel and created the first bathtub and sold it in lieu of 18 chickens and 2 lambs way back in 1873. And that's why innovation came. And today, I think this company, which is spread across the world, is one of the biggest, largest player, is basically giving ways and means so that you all express your freedom. That's what I saw when you were presenting. That's what you do day in, day out. And we are really glad and thankful with this association. And I think it should become stronger and stronger and bigger as we go in. And we'll be really glad to invest in this country and along with you, sir. Thank you so much for giving us this opportunity.
Thank you, Kohler and Mr. Tamal Keshaha. We have almost reached at the end of our today's event. In this stage, I'm requesting Architect Kazi Arif, Secretary IAB, to deliver his vote of thanks.
Thank you, Shehzad. We are absolutely at the end of this evening, but before we end, we must acknowledge the help and support and coordination from a lot of sectors and people before we conclude for this successful happening of this seminar. I must thank all the members of the seminar committee of the Institute of Architects Bangladesh, headed by Dr. Shehzad Zahir, for their relentless efforts. My colleagues in the Executive Council, most of the young stars there, have been working hard for the last several weeks to gather the participants and the speakers and the discussants, of course. All the staffs at IAB, they are working overnight for the last 3-4 days. All members who has participated this evening here, despite the interesting FIFA World Cup matches, I must also thank all of you, because without your presence, this evening could not have achieved the success it has. We have got support from all the support services, like the sound, lights, the LEDs, everything. I must also thank for them. They have been working with IAB for a long, long time. Must thank Kohler once again to be with us, and we have been in communication with Kohler for the last 5 months to organize this international seminar. Must thank these friends from Indonesia who has traveled a long way from Indonesia, and who had to go for little struggle to get the visa in a short time because of this Eid holidays. For the embassy in Jakarta were closed for 2 weeks. So we were in a tension that if we could reach here in time. I must also thank President of the Indonesian Institute of Architects, our good friend Ahmed Johara. I'm sure you would convey our greetings to him, because it was Ahmed Johara who inspired us to invite architects from Indonesia who are working with bamboo so passionately. So it's a big teamwork with everyone on board. I think it's a success, and credit goes to every one of us present in this hall. So with the invitation to the next event organized by IAB, let me conclude this by saying thank you very much, and we have dinner for everyone outside. So welcome to the next event of IAB. Until then, please take care, stay well, and stay blessed. Good night.